a Friday. Not sure whose it is, but the last day I will hold on to this. I was found in that area over there a couple days ago. So if you lost your reference sheet for activity series of common metals or solubility of ions reference sheet, I have it here. Claim it if you want it. How are things today, ladies and gentlemen? It is Friday. That's what happens after Thursday normally.
How was basketball?
How was basketball? I didn't die. I think that's a good thing.
That's a good thing.
So.
Playing with the basket.
Oh, heck no.
You don't.
Oh. So Eric beat you.
No, I'm not that bad. Oh, my God.
He beat me, Cole.
So, all right.
When we gotta go golfing?
You know what? I'll tell you what. On Tuesday, let's meet at the golf course, but don't start until I get there, okay?
Okay, sounds good.
All right, excellent.
Oh yeah, do you play with Mr. Good Eye?
From that all the way across the room and then repeated it.
He probably.
If you know the answer.
What?
You know the answer.
No, I don't.
Remember the independent integer?
Oh yeah, I'm still an independent variable. Till this day, I'm still an independent variable.
I got 2, 4, 6, 8, 10. 12, 14, 16, 18, 20. Wait, I got 20 of you here and I have 5 people. Jasmine. Never mind. I found the person I marked absent. Sorry. Okay. All right. You got a quiz today, ladies and gentlemen. Questions that you have before we do the quiz today. It's on paper. You have probably not having another quiz on computer all year long. Well, maybe. I don't know. We'll see. What? And then they wonder why they call you the generation that never listens.
What?
Exactly. Nice try, though. Good try, though. No questions? Certainly. Open up your EISN, ladies and gentlemen, and get to slide number. What the heck? Get to slide number 17.
Dude, I will see you live. I want to see, but like,
Okay. So, how many atoms are in 2.65 liters of nitrogen gas at STP? Slide number 17. How many atoms are in 2.65 liters of nitrogen gas at STP? Formula for nitrogen gas, Christopher.
Oh no.
N2.
Oh, N2.
That's it?
Yep.
That's all?
Yep.
That's what you're going with?
Yep.
Good. That's formula for nitrogen gas, N2, ladies and gentlemen. Now, in this problem, do you have to find formula mass? No, you don't. Why? Well, you're starting out in what unit? Liters, which measures volume. Atoms would be what? Atoms would be particles, ladies and gentlemen. Atoms would be particles. Now, you are going to need this, ladies and gentlemen. We're in volume. To get from volume into moles, what do we use? 22.4. Now, nitrogen gas, what are the particles? Right, they're nitrogen gas. Mr. Brand, obviously they're nitrogen gas, please. They're nitrogen gas, Mr. Brand. Good, what are the particles? That's even better, ladies and gentlemen. Then you wonder why we take an hour to get things done in this class.
Molecule.
It is a molecule. Technically a diatomic molecule, right?
The same.
So our smallest part has to be molecules. But then that molecule is made up of what?
Particle.
How many atoms? 2 atoms. So unfortunately, when we go to particles, ladies and gentlemen, particles is established by what the substance is. And in this case, ladies and gentlemen, the substance is nitrogen gas, which is N2, which is a diatomic molecule. So we cannot change the fact that it is a molecule, ladies and gentlemen. So our particles are going to be molecules, okay? But we can do one extra step in the end. So our problem begins, ladies and gentlemen, with what we are given. Now, these are the 3 conversion factors that we are going to use. 22.4 liters equals 1 mole. 6.02 times 10 to the 23rd particles equals 1 mole. And 2 atoms of nitrogen equal 1 molecule. What I should have put here was, I should have put 6.02 times 10 to the 23rd. 6.02 times 10 to the 23rd molecules. That is what I should have put there. Okay? So we begin with our 2.65 liters. The first conversion factor has to get us out of liters. So which one of those 3 do we use? The top, the middle, or the bottom?
Top.
The top. What goes where?
The 32 was on the bottom.
What goes on the bottom? I'm sorry?
Liters.
22.4 liters goes on the bottom, ladies and gentlemen. Okay? Sorry, I just marked Jasmine present, and I was not on the right screen to do this. Liters of nitrogen gas and liters of nitrogen gas will cancel. What unit are we left with if we stop now? Moles. We want to get 2 atoms. Which one do we use next?
The middle.
Why can't we use the bottom one?
Because there's no mole.
Because there's no moles in the bottom one, and we're in the unit of moles.
Yeah.
Now, I'm going to need to use this bottom one, but right now I wouldn't know how to set it up. Why? Because there's nothing I could cancel out with it. There's no molecules, there's no atoms, so there's nothing I could cancel out with. So I would have a chance of setting it up wrong. Now I got to use something else that has moles in it. That's the 6.02 times 10 to the 23rd molecules of nitrogen gas. Here I put it right. Here I didn't. Good. Okay. Over 1 mole of nitrogen gas. What unit are we in now if we stop? Molecules. But we need 1 more, which is what?
The last one, the bottom.
The last one, the bottom one. Good. Now what goes where?
The molecule goes on the bottom.
Good. Molecules go on the bottom. Now again, you can do this any way you want. If I were to do this on my calculator, ladies and gentlemen, I would do it all at once. And I would take 2.65 times 6.02 EE button 23 times 2. And then divide by 22.4. Now, before we go any further, how many sig figs?
3.
So I get 1.4243 times 10 to the 23rd out of my calculator. The third sig fig is the 2. 1.42 times 10 to the 23rd atoms. Questions? Good. I see some people typing. Keep typing. That's fine. You can take all day. It's all right. I understand you don't type as fast as I do. That's okay. It's okay. For right now, ladies and gentlemen, there aren't a lot of options for you. What I mean by that is our problems are either going to start out in mass, volume, or particles, possibly mole, but those would just be a one-step problem. and it's going to end somewhere else on here. So this one we started out here, we ended up here. But the only way to get from here to here is to go through moles. That's what we were doing with this first step. Then the second step, we were getting into particles. Excuse me. And then finally, ladies and gentlemen, because the particles were made up of atoms, and that's what it asked for, I had to have one extra step here. Okay? All we're doing each time, though, is canceling units, canceling liters, canceling moles, canceling molecules until we get to the unit we want. Questions? Ready to see another one?
Yes.
How many grams of aluminum sulfide are present in a sample containing 1.53 times 10 to the 25th molecules? Okay. Which one of those are we starting out with? Moles, particles, volume, or mass?
Mass.
Starting out with particles.
Oh.
What are we going to?
Oh, mass.
We're going to mass. So the only way we go from particles into mass is to use moles. The only way we get into mass is to have a formula mass. Okay? Here, again, this number is the number we use all the time. Here, this number is the number we use all the time. Here, we got to calculate it. Molar mass or formula mass, I don't care how we want to say it. Okay, aluminum sulfide, what is our smallest particle? Aluminum sulfide, what is our smallest particle? Don't look at your periodic tables. And actually, I got it wrong up here. What is the smallest particle of aluminum sulfide? What are the three choices? Atom? Molecule? How can you forget the last one? Thank you. How do you forget FU? How do you forget FU, ladies and gentlemen? Which one technically is this? Yes, I have it wrong. It shouldn't be molecules. It should be FUs. Why? Because aluminum sulfide is a what kind of compound? Ionic or covalent?
Covalent.
It's an ionic compound because aluminum is a metal.
Oh.
If you have a metal and a non-metal in a compound, ladies and gentlemen, it is technically a formula unit, not a molecule. Again, I told you we could use these interchangeably. And I guess so that you don't walk around the rest of the day going, hey, Mr. Brand taught us about FU in class today. We call it a molecule at times too. Okay? So, what are the conversion factors we need? What are we going to need?
6.02 times 10 to the 23rd.
We're going to need the 6.02 times 10 to the 23rd, and we're also going to need formula mass. Okay? So to write the formula mass, we need to write the formula for aluminum sulfide. Al2SO3 in parentheses 3. Now, the other day we did aluminum sulfate, and it came out to like 342.14. Okay? This, we have less oxygen with it, so that's why it's a little bit lower this time, ladies and gentlemen. Okay? A little bit lower this time. Okay? So those are the ones we need. We're going to begin with what we're given, 1.53 times 10 to the 25th molecules. Which of these are we going to use first? The one that has what in it? I'm sorry, I can't hear you, Shenza. Sorry, please be a little louder.
Molecule.
Okay, molecules. And technically, I don't have molecules in there. I have what? No, moles and molecules are not the same thing. What do I have in there in place of molecules? Particles. I have particles. Okay? So again, should have changed that. Again, in reality, I should have had 1.53 times 10 to the 25th FU. And 6.02 times 23rd FU. Okay? Molecules and molecules cancel. Formula units and formula units would cancel. What unit are we in? Moles. So what do we do to get to grams? Only one thing left, ladies and gentlemen. The bottom one, which is what? The bottom one. Thank you for clarifying that, Shenza. Much better, much better. The bottom one, which is the formula mass part. What goes where? On the bottom. I know, Shenza, I know. Mole on the bottom. 294.17 on top, ladies and gentlemen. By the way, if you are coming up with answers that are different than I have up here on your calculator, you are doing something wrong. If it's 10 times bigger, if it's 100 times bigger, you need to call me over and we'll try to correct it for you. But again, 1.53 EE25 times 294.17 divided by 6.02 EE23. You should come out with, again, 3 sig figs, 7,476.6493 out of your calculator. 3 sig figs, we round that to 7,480. Why? Only 3 sig figs are allowed. This 7 becomes an 8. What do we do with that 6? We put a 0 there to hold its place. Otherwise, we are changing the value of that number. Question? Yes?
So if we were going to calculate it to 7,480, what do we have to do that approximately?
No, I just do that so that you see that that's when it's rounded. That's what it actually is. Okay? Here's the thing. When you get this number in your calculator, Josh, if you want to write it in the correct sig figs right away, that's fine. But I just want to show you the number you get out of your calculator and the number you should be reporting are 2 different things. Okay? This is what we get out of our calculator, but this is what we have to round it to when we're done. I don't care if you do it right away. You don't have to write this down and then show me that you're rounding it. You can just do it right away. Okay? Questions? How much space in milliliters would 2.25 grams of sulfur hexafluoride occupy at STP? Where are we starting here? Mass. Where are we ending here? Volume. And actually, we got to be careful because it specifically asks for what unit of volume?
Milliliters.
So this will give us volume in what?
Liters.
And then we need to use that 1,000 milliliters equals 1 liter to get to the volume that they are asking for. Okay? To get to the volume they are asking for. So here's what we're going to need. We're going to need the formula for sulfur hexafluoride. We're going to need 22.4 liters equals 1 mole. We're going to need 146.07 grams of sulfur hexafluoride equals 1 mole of it. We're also going to need 1,000 milliliters equals 1 liter. Okay? So we begin with 2.25 grams. Which one do we use first, top or bottom? Bottom. It has grams in it. Where does grams have to go in our conversion? Has to go on the bottom. Put grams on the bottom, put moles on the top. Grams will now cancel. Okay? Next, we're going to use the 22.4 liters and 1 mole. What goes where?
22.4 liters on top.
22.4 liters on top. Okay? Again, 2.25 times 22.4 divided by 146.07. Going to give us that, 0.34504 liters. Now, again, I expect you to know how to go from liters to milliliters. You do not actually have to show me that one conversion. I will give you credit for just doing it in your head, doing it on a separate sheet of paper, whatever. You don't have to show it to me, okay? How do we get from liters into milliliters? What do we do to it? We take this and times it by 1,000. We take that and times it by 1,000, okay? To get into milliliters, we're going to take that and times it by 1,000. Again, if you want to show it to me, you can. If you do not want to show it to me, you do not have to. Okay? You do not have to. But for those of you who are looking a little confused, the number that we got here, 0.345 liters. We take that times 1,000 milliliters over 1 liter. Liter and liters cancel. We're still doing unit cancellation. And we take that times 1,000, and that's how we get the 345 milliliters. 0.0345 times 1,000 is 345. Questions? Okay. So here's what we're going to do, ladies and gentlemen. I need to give you the quiz. This class gets out at what time? 10:22. So how long do you feel you need for the quiz? What, 10, 5 minutes? It's only 4 problems.
1 minute.
1 minute? Okay. Phoebe wants 1 minute, so at 10:21 I will give you the quiz.
1 hour.
Dang it, Josh. Thanks for pointing that out. Okay, we're not listening to Phoebe anymore. I will give you a half an hour to work on the test, okay, or the quiz. So what that means, ladies and gentlemen, is you have got about 19 minutes to work on problems. 19 minutes before we take the quiz. 19 minutes to call me over and ask questions. 19 minutes to get some help. Harry, talk about his girlfriend, Sherry.
I have no girlfriend.
Eric, you really didn't need to tell us that out loud.
I'm an independent variable.